All right, so it is 7:05. Again, welcome back to class 15, and today we are going to be learning about curved surfaces. So I'll go ahead and start sharing my screen. And just to give a heads up for today's schedule, whoops, not sharing, presenting. Today, so we're going to, I would say, lecture from 7:05 to 7:45, and then we can go ahead and take a 5-minute break, and then after that we will keep lecturing, and then for the last 15-ish minutes we can go ahead and play a Kahoot. I don't happen to my screen. The presentation's not, it looks like it's not loading, so I'll just open up a new tab.
Sorry, I had it was just that because we my family made dinner late and I had to finish in 5 minutes.
Ooh.
Yes, big oof.
Okay, so today we'll be talking about curved surfaces. And our first section is going to be dealing with cylinders. So a cylinder is a solid geometric figure with straight parallel sides and a circular or oval cross-section. So as we talked about cross-sections in the last lesson, it's basically when you can imagine cutting, let's say, the cylinder on the right in half horizontally or vertically or diagonally. So if you were to cut it horizontally, there'd be a circle. If you were to cut it vertically, that would be a rectangular shape. And then if you were to cut it horizontally, I can't exactly imagine it. I think I would have to I'm not really good at imagining things well with geometry, so I will definitely pull up an image later of a diagonally cut cross section. Okay, so the axis of the cylinder is the line connecting the base's centers, so in this case it would be OO, and the radius of a base is also considered to be the cylinder's radius. This, I would say, it makes sense because the bases are circles, so then yeah, it would just make sense that the radius of the base would also be the radius of the cylinder. And a right cylinder is a cylinder where its axis is perpendicular to the bases. So as you can see in this cylinder with the 90-degree symbols that we are given, we can tell that the cylinder is a right cylinder. And we can have cylinders that have wacky curvy bases. So for example, we have these two cylinders. This is still a cylinder. It's kind of a weird cylinder. This is also still a cylinder. I'm pretty sure this is called a parallel piped cylinder because it's slanted. And when we refer to cylinders, we're usually talking about right circular cylinders. So we usually I would say we don't deal with these wacky looking cylinders too much. I would say we deal with more of the general right circular cylinder.
I have a question.
Yes.
How is the middle how is the middle shape still classified as a cylinder, because it more looks like a celery when you cut it up?
Okay, so if we look back at the definition of a cylinder, it's a solid geometric figure with straight parallel sides and a circular or oval cross section. So if you look at this, you're going to at first be like, oh, this doesn't look much like a cylinder, but the top and bottom parts, they do have they are parallel sides, and it is like a three-dimensional straight figure. So this would be considered a cylinder. The second part of this definition is circular oval cross-section. I would say this applies more to the right circular cylinders, the cylinders that we're used to dealing with more often. But cylinders can also include these really weird ones. So basically, it's just for a cylinder to be a cylinder, it just has to have a top and bottom that is they're parallel to each other, and then I would say that the rest of like the height portion, or you could say that the volume is it's just curved. So this would have a it has a curved volume, or like the curved inside shape, because I mean it's a circle, and this one is also curved, and this one is also curved, if that makes sense. And yeah, so you can just and you can also kind of tell like, oh, I know this might be a really weird cylinder again, but they all kind of, I would say they have a similar characteristics, you know, with the top and bottom bases, and then the curvy height portion, I would call it. Or I don't know how to describe the portion between the top and bottom bases, but yeah, that's what I would. Those are the different characteristics that I'll try to identify to figure out whether or not we're dealing with cylinder. But again, as I said previously, we usually don't deal with these weird looking cylinders too much. Okay, so we're going to start off with a problem. And a right circular cylinder is depicted with the radius 3 and a height of 5. And we want to find the volume, find the lateral surface area, and then find the total surface area. So I will give you some time to figure out these three things. Now that I think about it though, we learned the formulas for the volume, the lateral surface area, and the total surface area in a previous lesson. So if, let's see. Okay, I'll give you some hints. So for the volume, remember that it's the area of the base times height. You can try to figure this out because I think in this case, right circular cylinders are pretty straightforward with the volume. It's not, I mean, yes, there is a formula, of course, but it's not like you have to memorize the formula in order to know it. You can figure out the formula based off of the things that we've previously covered. And remember that the lateral surface area is the surface area of it's the total surface area minus the surface area of the bases. So it would be this circular wrapping, I would say. That would be the area that you're trying to find. And then total surface area is when you add up the area of the bases and also, I guess, this one face that wraps around. Okay, I will go ahead and go over these problems. So the first one, as I previously said, the volume is going to be the area of the base times the height. So in this case, because we know that the radius of the base, which would be the circle, is 3, we would find the area of the circle, so that would be pi r squared, or pi times 3 squared, and that's going to be 9 times pi. So then, and then we know what the height is. The height was 5, so we would just multiply those two things together. So the volume would be 9 pi times 5, which is 45 times pi. When it comes to figuring out the lateral surface area, we don't have any tools to figure out the area of the curved surface. So what we can do instead is we can imagine that the cylindrical surface is made out of paper. And let's see if there's, it looks like I didn't include an image. But what you would basically do for this is you would, so you can imagine that you have the cylinder in front of you. You can unroll out the cylinder. And so then like you would have the top circular part and the bottom circular part, and they're like kind of like flaps. And then you can have the rolled out circular face. And that would actually end up being a rectangle. And here, let me actually go to the whiteboard for this, because I think that's an easier way to explain it. Oops, where did it go? Okay. Because, well, personally, I am a better learner when it comes to seeing the image in front of me. I know some people in this class also, they like to have an image reference when it comes to learning. So I will make sure to put one. Okay. Actually, we'll have two solutions. So here's the first image. And then we have the second image. Where is it? Solution, there it is. Okay. Okay, in case I have to write something out, I'll just have space over here. So as I was saying, what you can do to figure out the lateral surface area is, so you would roll out this cylinder so that you would have this you would end up having this rectangular shape. So then you could see that this is the circumference at the top, and then this would be the height, and this is the circumference of the bottom. So then this would actually, as you can see, it's a rectangle. So then all we would have to do is figure out what the dimensions of the rectangle are and then find its area. So the dimensions of the rectangle is going to be the height of the cylinder times the circumference of the cylinder as shown. So then, because we know that the height is equal to 5, and that the circumference, is going to be 2 pi r, and we know that the radius is 3, so then 2 pi times 3, that's going to be 6 pi. So what we would have to do is just multiply these two together. So then we would get 5 times 6 pi, and then that would equal 30 pi. So that is our lateral surface area. Okay, finally, for the total surface area, what you would do is add the bases, add the bases and then add the area that we just found. And each base has the area. We actually already figured this out when we were calculating the volume, but the area of each base, that's going to be 9 pi, as we previously figured out. So then it would be 30 pi plus 2 times 9 pi, and that's going to be equal to 48 pi. So that will be our final answer. Okay. All right. So now that was like more of an introduction, maybe it helped you to try to think out of the box and try to figure out the surface area, the lateral surface area, and the volume of a cylinder without knowing the formulas. Maybe it helped you a little bit more with that. You know, you can apply the knowledge that you've already had, and you can apply it to stuff that you're currently learning. But we can go over the formulas that exist when it comes to learning about cylinders. So a cylinder that has the height h and radius r has the following. So the volume is pi r squared times h. I think you figured that out after we finished the problem. The lateral surface area is 2 times pi times r times h. And then the total surface area is 2 times pi times r times h plus 2 times pi times r squared. And so this is just a side note. You don't always have to memorize these formulas. You can take the time to understand them, and they'll naturally come to you, but you can memorize them if you want to. But the way that we did it in the previous problem, I think that would definitely help you with your problem solving skills. And of course, if you're the type of person who likes to memorize formulas, then go ahead, you can memorize these formulas. But I think the way that we just did, or the way that we just figured out the problem was also an efficient way to find the values of these 3 different things. So I'll leave this up here for a few seconds just to look over the formulas. Of course, they're on the internet, so if you forget it anytime, you can always search it up after class. Okay, so next we have problem 15.3. A cylinder has a radius that is 2/3 its height. Find the total surface area of the volume that is 96 times pi. So let's see if you guys can figure out this problem. I'll give you some time to do this one, and then we can go over it together.
Okay, something unrelated.
Yes.
This is drawn. My virtual background is drawn.
I want to see. I'll check your virtual background because I can't see anybody right now. I can only see the presentation, but I'll make sure to check out your virtual background when we're on break.
I have a suggestion to finding the radius. First, you divide 96 into let me think about what you're supposed to divide it in.
Okay. I can give a hint out. What you can do is establish a variable for height, and then you know that the radius is 2/3 of the height. So then you can come up with a formula for radius that corresponds to height.
I think it's if, not of.
Oh yeah, thank you for the. I didn't catch that typo. Okay, I'll give you a few more seconds and then we can go over this problem. Okay, I will go ahead and go over this problem with the whiteboard. Okay, So we weren't given an image for this one.
I
so
can make my video disappear. I can make myself disappear. All you need to do is go up to the camera and then completely cover it.
All right. Oof, that's a weird cylinder. Okay. So we're going to let the height, oops. So, no, I don't want to move anything. There we go. Okay. So we're going to let the height equal h. So then that means that the radius, this r stands for radius, that's going to be 2/3 times the height, or you can say 2h over 3. And we know that the volume is equal to 96 pi. So then, and we know what the formula for the volume of a cylinder is. So then we can make the volume, the given volume, equal to that formula. So then it's going to be 96 pi is equal to pi r squared times the height. And then we know we don't exactly know what the value of the radius is, but we do have this formula right here. So then we're going to substitute it in. So we would get 96 pi is equal to pi times 2, whoops, not pi again, 2h over 3 squared, there we go, times the height. And then we would, yeah, okay, there we go.
Excuse me, I'm sorry. Could you go back to the question?
You want to go? Okay. The question was, a cylinder has a radius that is 2/3 its height. Find the total surface area if the volume is 96 pi.
Oh, okay.
Yeah. Here, I'll just make
also, Alvin, are you on a couch or are you on a bed?
Couch.
Okay.
Okay. Okay. So here, I just made a side note that we're finding the total surface area. Okay. So if we were to simplify this, or if we were to multiply this out, we would get 4h cubed pi over 9, and that's going to be 96 pi. So then eventually you can multiply 96 by 9, and then the pi's would cancel out. So then you would get 4h cubed is equal to 864. So then you can divide 864 by 4 to get h cubed is 216. So then, and if you solve for h, you would get 6. And that's the height. So we plug that back into the formula that we derived for the radius. So that would be radius is equal to 2 times 6, which is 12 divided by 3. That's going to be 4. And that means that the total surface area is going to be 2 pi RH plus 2 pi r squared. And if we were to plug in the values, we would have 4 times 6, 24 times 2, that's going to be 48 pi. And then we would do the same thing, we plug in values. We know that the radius is 4, so that's 4 squared, 16. And 16 times 2 is 32, so that would be 32 pi. You would add together those two values to get 80 pi. So that is your answer. I'll leave this up here for a few more seconds and then we can go on to the next section.
Alvin got a fire background, but my fire background better.
Okay, so to learn about cones. So a cone is a three-dimensional geometric shape that tapers smoothly from a flat base to a point called the apex or vertex. So for example, we have here a right circular cone. This is a right circular cone because you can see that the apex is directly above the center of the circle. So then that would create a 90-degree angle right here. So that would be a right circular cone. And point A, that's the apex or the vertex. And the distance from the vertex to the base, that's the height. And the axis is the line connecting the vertex to the center of the base. And for right circular cones, we have the distance from the vertex to the point on the circumference of the base. So in this case, it could be AB, or it could basically be any point that's on the circumference, and that's going to be connected to the vertex of the cone. That's going to be known as the slant height. And cones don't have to be right or circular, so this is going to be, I guess you could see that it's like a slanted cone, and then this cone has a really weird looking base, as we saw with the previous weird looking cylinder. Okay, so I'll leave this up here for a few more seconds, and then we can go on to the next slide.
The cone in the lower right corner looks like
It's the cone celery. The cone celery.
Celery.
That's an interesting way to think of it.
My brother, he will not like seeing this. He doesn't like things that aren't normal shapes to him. So if he sees this, he will be like, exactly what the fire dragon is like.
Who is he?
He is 3 years old.
Oh, he's cute. That's cute. Oh, I want to have a 3-year-old brother. All right. So next, we have the volume and lateral surface area. So the volume is 1/3 times pi times r squared times height, and the lateral surface area, and this would apply to a right circular cone with the radius r and slant height L. That's going to be pi times r times L. So for this one, I usually memorize the volume of a cone. I think, for example, for like some of these standardized tests that you take in high school, I would say it's probably a good idea to memorize, especially the volume and area formulas for the different shapes and 3D shapes. But yeah, I mean, it's up to you. Again, you can, actually for cone, I would recommend learning because it might be a little bit harder to derive the formula just by using like the problem solving skills that we used to figure out what the formula of the volume for a cylinder was. But yeah, just a little heads up. Okay, next we have this problem. What is the shape of a cone's cross-section that includes the cone's axis? And what is the shape of a cone's cross-section that is perpendicular to the cone's axis? So if we want to go back, An axis is the line connecting the vertex to the center of the base. Okay, so now that you've got like a little refresher of what an axis is, you can go ahead and try to figure out these two problems.
Can you go back to the cross section?
Okay. I don't know if I covered cross section, but remember, cross section is when you basically cut the shape in half. Imagine you were slicing the cylinder in half, and the shape that you would see on either side of the two shapes that you just cut, that would be the cross section. So just imagine like you're cutting the cylinder in half. What kind of shape would you get? What kind of shape would you see?
My creative side would just say it would be a pyramid, but with rounded edges on the rounded base and base edges. But my normal self would just say it's a cone cut in half.
Oh yeah, okay, cross section, it's the 2D shape that you would get. So, okay, going back, let's say you cut the cylinder in half. So then the cross section shape would be the shape that results if you were to look at, for example, if you cut it right here, then it would be the base of the smaller cone that you just got, or it would be the top base of I don't know how to describe the shape of what is left of the original cone, I should say. Okay, I'll give you guys a few more seconds to attempt this problem, and then we can move on to the next slide. Okay, so the cross-section of a cone that contains the cone's axis has two segments of equal length connecting the vertex to, okay, wait, actually, this is complicated, so I will finish. Let's see, because I just, when I was learning all this stuff, I remember that I'm not doing real with words. So let's get this image out. Just ignore. Okay. Let's place this one, and then we have another image to place. Okay. Okay, so as I was saying, so imagine if you were to cut the cone vertically, like, whoop-pow, you got a knife out and you cut it vertically. The shape that you would get is, you would get a triangle. And if you were to think about it, you would get an isosceles triangle, because the slant height is going to be equal all the way around for a right circular cone. And then as for cutting the cone horizontally, if you were to cut it horizontally, so yeah, you got a knife, well, pow, you cut it horizontally, you would get a circle. So yeah, this is when it comes to figuring out these cross sections, I would say it's a good idea to just try to imagine, okay, I'm cutting this shape this way, I'm cutting this shape that way. What kind of shape would I get as a result of the way that I cut it? So yeah, that is pretty much it. with cross sections. Okay. So next we have this problem. So a right circular cone has a radius with a length 6 and a slant height with a length 8. And you want to find the volume. Hint, hint, you can use, because you need the height, remember slant height and height are two different things. In this case, slant height would be AB, but the height would be AO. And you can use the Pythagorean theorem to figure out what the height is. Okay. So go ahead and go to the whiteboard. And we want to start drawing. Okay, so what we would need, of course, is the height, but we don't have it. But we know that, whoops, the radius is 6, and then we know that the slant height is going to be equal to 8. So with that in mind, we can go ahead and label our figure. So then we would solve for AO, and we can use the Pythagorean theorem to do this. So if we apply the Pythagorean theorem, we would get AO squared plus OB squared is equal to AB squared, and we want to isolate AO. So then we would get AO is equal to the square root of AB squared minus OB squared. And we would plug in the values that we know. So AB, that's going to be 8. So 8 squared would be 64 minus OB squared. We know OB is 6, so OB squared is 36. So then 64 minus 36 is going to be 28. And if we were to simplify that, we would get 2 square root 7. And then now that we know what the height is, all we have to do is just plug it in to the volume formula, which is pi r squared times height, and I'll just put the 1/3 out in front. So then that would be 1/3 times pi and times the radius, which is 6, so 6 squared times the height, which is 2 square root 7. So that is going to be, if we were to simplify that, let's see, we can always plug that back in. Okay, so be 36 divided by 3, so then you would get 12 pi. I'm going to multiply the 2 back, or plug it back into the square root, so that'll be 4 times 7, which is square root 28. Or actually, no, what am I doing? You can just multiply 2 times square root of 7. So then you would have 12 pi times 2 square root of 7. So that's going to be 24 pi times the square root of 7. And that will be your final answer. Okay, I'll leave this up here for a few more seconds, and then we can go ahead and go back to the slides. And it's actually 7:45, so we can go ahead and take our break for 5 minutes.
Okay.
All right.
Alvin, think it's time.
To do what?
PVZ.
Not now. I have to eat.
You have to eat. You forgot lunch? I mean dinner? You
Yeah,
forgot-
I didn't eat. I usually eat dinner at around this time.
Mhm.
And also because Scratch isn't able to handle so many plants, so we'll only do at most 20, okay?
Okay.
And I can't do so many effects.
Because Scratch is so easy, I think I can help you with.
I've got to,
Okay, so it's 7:50, so we'll go back to where we just left off with problem 15.7. So a semicircle is rolled up so that it forms a cone. If the semicircle's radius is 8, what is the cone's volume? Wait.
Wait, doesn't the net of a cone also include that small circle there?
So what of the cone?
The net of a cone. Doesn't it also include another small circle for the base?
The net of the cone?
I think he meant the base. Yeah, he meant the base.
Yeah. Oh, okay. If it includes a small. Yes, it does. Whoops. Yeah, it does. But this is just imagine that you can see that it's like rolling it out. So there should be like we could say a flap, like a circular flap somewhere attached to this rolled out cone.
Just imagine it just all rolls up into a cone.
Yeah. Okay, so I'll go ahead and go over this problem. And
The semi-radius must equal 4, right?
the semi-radius, yes, it would equal 4. Okay.
Phew. I still have a chance to solve this.
Open this. Okay, I'm going to have this here. And then I will also have the and then I think I'm not sure if there's another image if I have to saved. I'm pretty sure I got all of them up though. 15.7. Hold on. I'm going to sorry, I was gonna sneeze, but that was kind of a late warning. Okay. So let's record the information that we were given. So the semicircle's radius is going to equal 8. So we want to figure out what the radius will, or actually we want to figure out what the volume, sorry, not the radius. Okay, so in order to figure out the volume, we have to find the radius and the height of the cone. And we can use the rolled out cone to figure out what the radius is. Okay, so for the first, there are, I'm pretty sure, 2 methods. Yes, there are 2 methods that we can use to figure this information out. So when we roll the semicircle into a cone arc, so you can see this is arc BCV, that becomes the circumference of the cone's base, as you can see. And since the semicircle's arc is 1/2, here, let me. So since the semicircle's arc is 1/2 the circumference of the circle with the radius 8, here. I'm just going to record the length of it. But yeah, because it's 1/2 the circumference of the circle that has a radius 8, the length of it is going to be 8 pi. Because it's going to be 2 pi r divided by, oh no, sorry. Yeah, 2 pi r, that would be circumference, but we're dividing it by 2, so then you would get 8 pi. Hence, the circumference of the cones, because the circumference of the cone's base is 8 pi, that means that the radius must equal 4. Okay, and so that was one method that you could have done. There is another method that you could have solved, or you could have figured out, but I think that this method is the simpler one. So now that we have found the radius, we can find the height by using the right triangle AOB in the cone. So then we would get the formula AO. I'm just going to, I think you guys know what the process is of, with the Pythagorean Theorem, plugging in numbers, isolating AO, square root. So I'm just going to do all of that really quick, and then I'll just plug in the numbers. So that would be square root of 8 squared minus 4 squared. So that's 64 minus 16.
4 squared, which is equal to 4.
Yeah, or 4 times square root of 3. So then the volume is going to be pi times r squared times height. And I'll just include the 1/3 in the front. And if you plug in the values, or let's make the 3 1/3. Let's make it pi r squared times h over 3. So then that would be 64 times pi times the square root of 3. Note that I already combined the values, so we just have the square root 3 out here, and then we already have 64 pi in the front, and this is going to be over 3. And let's see, can we simplify? No, looks like that's actually a simplified form of the volume. So that will be your answer. That is what the volume of this cone is. So I will leave this up here for a few more seconds, and then we can go ahead and go to the next slide.
The Kahoots?
Not yet. Later, though.
Just asking.
Okay. So next we have this slide. Okay. So similarly to how the ratio of the areas of similar 2D figures is the square of the ratio of their corresponding sides, the ratio of the similar 3D figure surface areas is the square of the ratio of their corresponding side lengths. So furthermore, the ratio of the similar 3D figures volumes is the cube of the ratio of their corresponding side lengths. So this is just information about ratios. I would say this is more advanced information, so I wouldn't worry too much about it for now. But once you get to learning geometry, you can start paying more attention to ratios. And okay, we can go ahead and go to the next slide. And next we're going to learn about spheres. So sphere, examples of a sphere, I think we've all come across spheres: tennis ball, soccer ball, basketball, ball. Yeah, so a sphere is a geometrical object in 3-dimensional space that is the surface of a ball. And the radius of a sphere is the distance from the sphere's center to the sphere's surface. So the sphere radius r has the volume, which is 4 times pi times r cubed divided by 3. And it also has the surface area, which is equal to 4 times pi times r squared. So we'll make sure to come back to these formulas because we might need them for future problems. Oops. I'll leave this up here for a few more seconds, and then we can go on to this next problem that we have.
Like basically, after that, you have the hypersphere, which is in 40.
All right. So a sphere's volume is numerically equal to twice its area. Find the sphere's radius. So let's okay.
What is a sphere's area?
Hmm?
What is a sphere's area?
Oh, I meant to type surface area. Sorry. Not paying attention to what I was saying. That's supposed to say surface area. That made no sense. Okay, sorry. So I'll leave this up here for like 5 seconds, and then we can go back to the previous slide to look over the formulas. Okay, and here are the formulas. And remember, the volume is supposed to be twice its surface area. And you want to find the sphere's radius. Okay, I'll go ahead and go over the answers.
Can I like give my explanation?
Yes, go ahead.
So I got r radius r equals 6. So the surface area of a sphere is 4 pi r squared, and the volume of a sphere is 4 pi r cubed over 3. And because it equals to 2 times its surface area, so I wrote an equation. 2 times 4 pi r squared equals 4 pi r cubed over 3. Multiply both sides by 3. 24 pi r squared equals 4 pi r cubed. Divide 4 on both sides. Divide pi on both sides. And because r is definitely not 0, so I can divide r squared on both sides. And I got 6 equals r.
Nice. And that is the correct answer. So yeah, basically you would have multiplied surface area by 2, set it equal to the volume, simplify, and then get the radius. So that problem, once you figured out the logistics of it, it should have been pretty straightforward after that, once you set them equal to each other. Okay, next we have problem 15.10. Prove that if a plane passes through a sphere's interior, then the intersection of the plane and the sphere is a circle. So you can also imagine that you're cutting the sphere in half, again, pow, and then you can think about the cross section, and then you can figure out why the cross section or the intersection of the plane and the sphere is a circle.
I would say that because a sphere is a round shape, the interior of a sphere would be a circle. And if a plane happened to pass through it, the intersection of this plane and the sphere is the interior, which is a circle.
Yeah, that's kind of pretty much it.
That's what I tried to say.
Yeah.
Like basically, you can think of it a way like a sphere is basically you start from a dot and then which has a it's made of circles and from top to bottom, and the first circle is a dot with radius 0, and then you make the radius larger and larger and larger and larger, and when you get to the you just make the larger, and when you get to the middle you just make it smaller, 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 smaller. So in this way, like basically, if you cut a sphere, it is always a circle.
Yeah. All right, so it looks like you guys pretty much got that down. So we can skip that explanation and then go to the next slide. Okay, so every cross-section of a sphere is a circle or a point when the plane's cross-section is tangent to the sphere. Remember, tangent means that it's when, so in this case, it's a plane when the plane is touching the sphere at exactly one point. So it's like literally brushing the sphere and touching it at exactly one spot of the sphere. Okay, the segment connecting the sphere center to the center of this circle is perpendicular to the cross-section's plane. I think, okay, so let's imagine, let's say that we had a tennis ball and then we had a piece of paper that touched the tennis ball at exactly one point. So the piece of paper was tangent to the tennis ball. So the imaginary segment that would be connecting the surface of the circle, the point of tangency to the sphere's center, that's going to be perpendicular to the paper. Okay, and the great circle of the sphere is a sphere's cross-section that has the sphere center as its center. So that's when you literally cut the sphere in half, and then you would see the cross-section that results. And that's the great circle of the sphere. Okay, next we have problem 15.11. So a plane cuts through a sphere with a 26 centimeter diameter, but the closest it gets to the center is 5 centimeters. What is the area of the sphere and the plane's intersection? Okay, let's see. One way, I'll give you a hint. Maybe you can try to figure out what this length XO would be. So if you know what the diameter is, then you can figure out the radiuses. And we know that the closest it gets, the closest the plane gets to the center is 5 centimeters. So you could do radius minus 5 to figure out what this length is right here. Or actually, you know what? Discard the hint that I gave you. Because if you look at this carefully, OA is actually the radius of the sphere because it's stemming from the center to the sphere's surface. So this would be 13. And Actually, OX would be 5 centimeters. I misunderstood the problem, but yeah, OX would be it would be 5 centers because that's 5 centimeters away from the center. So I'll give you guys a few more seconds and then we can go over the problem. All right. So I kind of gave 2 pieces of crucial information away. So we know that the diameter is 26, and that means that AO, or the radius, would be 26 divided by 2, just 13. And then OX, I just kind of explained it where it would be 5. So then what you would need is XA. So you could use the Pythagorean Theorem because we know that we're dealing with a right triangle. So then AX would be square root of 13 squared minus 5 squared, which is 12. You might have recognized that this is one of the Pythagorean triplets, or triples, not triplets. And we know that this cross section is going to be a circle. So then we would have gotten pi r squared, or 12 squared times pi, which is 144 times pi centimeters squared.
What's the problem?
The problem was what is the area of the sphere and the plane's intersection? So you just wanted to find the circle that resulted.
So that was the solution?
Yes.
Okay.
All right. Okay, let's go over this problem and then let's see how much time we have left and see if we can go ahead and play the Kahoot. Okay, so a sphere is inscribed in a cube, meaning that the sphere is tangent to all 6 cubes' faces. So you can imagine that you have a box that is a cube. And let's imagine that you put a tennis ball in it so that the tennis ball is touching all of the faces of the box. Okay, so second cube is then inscribed in the sphere so that all 8 vertices of the second cube are on the sphere surface. So let's say that we cut open the tennis ball and we can say we put in a dice. That's like, let's say that was a pretty big dice and it touched all of the tennis ball surfaces, or tennis ball surface. Given that the sphere's radius is 6, find the volume of each cube.
So you're saying that we cut open a tennis ball, put everything outside, and then put a very big dice in it?
Yes.
Okay.
I'll give you guys just a bit more time, then we could go over this problem. Okay. So to find the larger cube's edge length, because what we're trying to do here is we want to find the volume of each cube, we're going to have to find the edge length. We want to consider the cross section that includes the sphere's center and the 4 points of tangency where the sphere touches the cube at the centers of the cube's faces. So in other words, we're going to be looking at this picture up here. So the sphere's cross section is a circle. And since the circle includes the sphere's center, the sphere's radius is also going to be the circle's radius is also going to be the sphere's radius. So the cube's cross-section is a square where side lengths equal the cube's edge lengths. So we want to draw radii to points of tangency at E and F, and we can figure out that AEFD is a rectangle and EF is the circle's diameter. So AD is going to be equal to EF, which is going to be equal to 2 times OE since we're given the radius. That's going to be 12. And the large cube's volume is going to be 12 cubed, which is 1,728. Okay, I'll leave this up here for a few seconds and then we can go on to the next slide. Okay, there are several ways to find the smaller cube's volume, so we can start with the cross-section. We want to include the sphere center since we know the sphere's radius, so we include the sphere center and 4 vertices of the cube as shown, and x, y, and yz, x, y, and yz are going to be diagonals of the cube's faces, while wx and yz are the cube's edges. And since wy is also the sphere's diameter, wy is going to be equal to 12. So because wy is the small cube's space diagonal, the small cube's side length is going to be wy divided by square root of 3, which is 4 times the square root of 3. So then the small cube's volume is going to be 4 times the square root of 3 cubed, which is 192 square root of 3. And note that I am pretty sure, I can't remember what the formula of the space diagonal is exactly, but that is how you would have gotten this value right here, by figuring out, by knowing what the space diagonal's formula is, and then you would have figured out the side length from that. Okay, so it is 8:17, 13 minutes to class, so I'll go ahead and...
They're gonna have to be really...
Kahoot!
Cahoots! Cahoots.
Can play Kahoot.
Also, we really need to hurry because we only have 13 minutes left. Unless if we go over time.
Yeah, whatever.
We can go a little bit over time.
Tried the Kahoot
It'll
app.
take 13 minutes. I'm already ready.
Your screen is frozen.
Pen.
Alright, 467.
Okay, 4674009. There, I'm in. Okay, wait. There. Yay, first person. Ah.
I'm the first person.
1 millisecond
Have to
before me.
destroy everybody.
You're literally 1 microsecond, or no, 1 nanosecond before me.
Yeah, it's called nanoseconds.
No, it's no 1 yada. No, whatever it's called, 1 yet a second. Yada.
No, nanosecond is the smallest measure of time for now. I mean, right now, it's a nanosecond is the smallest time measure.
Wait a second.
He's searching it up.
Wait. Which one is smaller? A yoctosecond or a nanosecond? Wait. What is
Number
the
11.
smallest unit of time? No, it's the Planck time. Planck time is smaller than a nanosecond.
Wait, yoctosecond is smaller than a nanosecond?
Yeah, no. Yoctoseconds are larger than nanoseconds, but Planck time is even smaller than nanosecond. Nanosecond is smaller than yoctosecond. Yeah, you're right. But Planck's time is actually the smallest.
Wait, who put the doom shroom in here? Who hitting it with the doom shroom?
IDK, but we're not adding that to our PVZ
Alright.
Infinite.
Explain yourself.
Doom streams are boring.
No, doom streams are okay, but the problem is they nuked up the whole place.
Yeah, I know. I don't want to waste my space.
The complement of angle M is 10 degrees. So that is the measure of degrees of angle M.
Hi, PPL. Okay. Nobody got it wrong. Okay. Hi, Alika. Why are you number 11?
Elika.
Okay, whatever. Why are you number 11? If a 12-hour class, and what is... I read the question.
12-hour clock analog clock reads 8 o'clock. What the measure degree of the smaller?
Oh, the smaller angle. Come on. Dang it.
Wait, it's 4. So 12, 360, 120.
Dang it. I got it wrong.
I got it right. And
Whatever.
What? Dang it, I'm still in 4th place.
Triangle A, blah, 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 blah. Why is this question so long? Can you give me a question? Can you picture? Thank you.
So,
Find angle
this is
A,
15, so too easy.
55, LOL. Sorry, I said the answer.
It's not the answer.
Wait, what? How is it not the answer?
It's not the answer.
Sure, whatever, if you think it's not. Told you it was. It was the answer. Thank you for your spot.
You know that we still have 10 questions left.
Is at the circle center, what percentage
If the angle vertex is at the circle center, what percent of the circle is shaded?
I'm gonna sue because the correct answer isn't here. 33.3 isn't the percent. It's 33.3 up to infinity.
No, we know. It's just trying to simplify it so we don't have to get a headache. Trying to count all those 3s.
I know. At least make it the max. What is the value? Whoever gets this wrong is gonna get grounded.
No more rice for you.
Good thing nobody is grounded.
No, it's no rice for you. Oh, dang it, my little brother is here.
My name is settlement of the settlement of an angle measuring. Yeah, great. I got it wrong.
I got it wrong.
Yay! Thank you.
And you get to see part of my brother.
What? Whoever gets this wrong is gonna be grounded for 1 minute. Okay.
Nobody got it wrong. And I'm still
Right, nobody's grounded.
She was in 1st place.
Find the value of x. Is this
So now what? Whoever gets this wrong is gonna be grounded for 1 year.
什么都知道，我只是给我自己，不放了自己。
Who is that?
I have a question. What took somebody so long?
Who is that? Yeah.
Ging ging.
What the?
8 raised form
8 raised form congruity, 1 raised form, whatever. Give me a picture.
Yes.
Okay, find measure of east and
East,
southwest. Oh my gosh. What the heck?
There's 1, 2, 3, 4, 5, 6, 7,
Whoever
8.
gets this wrong is going back to geography class for 1 year.
Geography?
Yeah.
Geography class, that one was a little bit easy. Sorry. But
Whoever gets it wrong is going to geography class and is going to geography class, gonna be grounded by their geography teacher and gonna learn geography nonstop 24/7 for 1 year.
Why are you so hard?
Oh my god. Someone really got it wrong.
Who got it wrong? Oh, how
That
you
guy doesn't know the directions.
How you got it wrong? So,
It's okay. Mistakes. You learn from your mistakes.
Complementary means they the sum is added up to 90 degrees, right?
Yep.
Of course. Whoever gets this wrong is going to be grounded for 1 second.
All right.
This is
that
actually
was
a pretty easy
What?
question that we're
Okay, no one's gonna be grounded.
nice.
Right,
Alka took
that was
first
the
place.
bottom rank. Quiz, two complementary angles have a ratio of 3:2. What is the measure of in degrees of the smaller angle?
Okay. What the?
快点给投给我自己，不忘了自己。
Whoever gets this wrong is gonna be grounded for 1 hour.
1 hour? That's a little bit too nice.
Whatever. And nobody.
I think our method of motivation is actually working.
Find X. What the? Oh, this is way too easy. Whoever gets this wrong is gonna be grounded for 5 years. And apparently nobody did. Come on.
Hey, be positive. Somebody actually got it wrong.
Really? I don't believe you, you know.
No, I mean somebody got it wrong before.
Yeah, but that guy going to geography class.
No rice for you.
And apparently nobody got it
No
wrong.
rice for you. No sleep for you. Yep.
No sleep for you.
No rice for you.
What is the supplement of the Okay, what the heck? I'm gonna
The
I'm
Greek
gonna
version of the
go
supplement
play-
of the complement of a 42-degree angle.
what the whoever gets this wrong is gonna be grounded for 5 minutes. Okay, aka 5 centuries. The last question is always the harshest. Whoever gets it wrong is gonna be grounded for exactly 5 cents.
Oh,
Why am I the only one that got it right? So
Yeah.
okay.
That's one is not working.
So first you would have figured out the complement of a 42-degree angle. So that would have been 90 minus 42. You'd have gotten 48, and then you would find the supplement of the 48-degree angle. So that's 180 minus 48. You would have gotten
for you.
2.
Subtraction problems. At least in 3rd place.
Mark, I tried my best.
Yeah, you're gonna be grounded for 5 centuries.
Doom Shroom.
Nice
Who even
job.
plays Doom Shroom strategy now?
I don't know, but I hate doom shrooms. They're useless.
The only way good Doom Shroom is good is wiping out football zombies in hard mode.
Yeah,
Oh
whatever.
my. Wow. I didn't know. Oh, it is upside down. Okay, so we have 2 minutes left, but
Let's play another Kahoot.
I'll just say we can go ahead and end class.
Come on, another Kahoot.
Alvin,
We'll
it is
play another
time.
Kahoot next time. But bye, guys. See you next
Bye.
time.
Yeah,
Alvin, you know what time it is.
8:40, you said.
Yeah.